Whoa, what are you doing? You can't be literate.
Wait, I heard it'll decompose.
Where did you learn that from?
TheOnion.com.
The Onion, that's not even a reliable source.
Wait, then what do you know about plastics?
Well, my lab partner.
Regina.
Oh, well, okay, so Regina and I have been doing a lot of research.
Yeah, so current discoveries say that there's greener alternatives to your non-degradable water bottle, you know? Wait, like what then? Bioplastics. Wait, what the heck are bioplastics? I mean, they're just like plastics, made from renewable resources, but they're biodegradable in the environment.
Here, take a seat.
So, bioplastics are plastics or polymers that are processed from renewable resources like cassava or corn and are biodegradable to the environment.
And the issues with petroleum-based plastics as opposed to current bioplastic is that 95 to 99% of plastic is manufactured with petrochemical products and non-renewable resources. And these synthetic petroleum-based products can undergo physical, biological, or chemical degradation processes that results in huge buildup of non-biodegradable waste. And these plastics that are left in the ocean can remain unaffected for thousands of years, leaving small fragments and nanoparticles of plastics that can harm human health and marine life when it does eventually break down. Greenhouse gases that are released from breaking down petroleum-based products decrease the quality of the environment and trap more solar radiation, which can lead to global warming and health issues.
Wait, so why don't we just all switch to using bioplastics?
It's not that simple, since current plastics require heavy refined machinery and facilities to break them down, which many countries lack the resources and accessibilities for, leading to more plastics being dumped into the landfill. And the misleading belief of current bioplastics in today's age is that they're all 100% biodegradable, but approximately only half of today's bioplastics are actually biodegradable. However, recent studies of bioplastics show potential of a greener alternative to your everyday plastic. Newer discoveries shows hope that manipulating various forms and structures of bioplastics can result in a more sustainable and renewable everyday resource.
We did some research. Here's what we found. Polylactic acid, PLA. It's a chain of thermally processable polymers that's based on cornstarch, and it's broken down into sugars. These forms of lactic acid influence the polymer and can be structurally adjusted to fit different needs of bioplastic products. More sturdiness, malleability, transparency. PLA is present in an amorphous state, which makes it a better alternative for plastic bottles, cups, degradable films, cutlery, etc., since it can be manipulated any way that we want. Chemical hydrolysis is a process that PLA undergoes, and it creates a more sustainable biodegradable resource. Through this process, the material is exposed to high humidity and temperatures, where the high oxygen and water molecules allowed the PLA to compost into carbon dioxide and water. So the process of polylactic acid hydrolysis includes hydroxide ion, which bonds to the carbonyl carbon atom. Then the bond between the carbon atom and the oxygen atom are broken through electron transfer. Then the oxygen atom bonds with the hydrogen atom, which is from the water molecule. This continues until the PLA polymer chain is fully broken down to lactic acid. Through this process of chemical hydrolysis, the PLA becomes more compostable, more biodegradable for composting facilities, and consumed by environmental factors. This allows for a more feasible and environmentally friendly alternative as compared to your everyday petroleum-based products.
Here's one of the discoveries from a research article that I found while researching. This discovery shows that manipulating fibers retrieved from gum Arabic exudate, or GA, with methane plasma and Y-ray radiation can be useful. The different treatments resulted in the bioplastic fibers to react differently in terms of shape, structure, hydrophobic and philic tendencies, and even antioxidant properties. GA treated with plasma resulted in a rougher structure that has a water contact angle of roughly 130 degrees, making it very hydrophobic. And GA treated with Y radiation has a water contact angle of 80 and non-treated with an angle of 60 degrees. When their antioxidant capabilities were tested, it was discovered that the GA that received any sort of manipulation showed great signs of antioxidant properties, with the GA with Y radiation being the greatest in antioxidant, making it resistant to bacterial growth in some cases. This means that potentially, bio-based polymers have the potential to extend the shelf life of food products by combating the growth of pathogenic bacteria.
The current state of plastic consumption and degradation hasn't been so kind to the health of the world. It's a problem that needs to be tackled to prevent further global warming, plastic pollution, marine and human health. Recent studies have made it clear that bio-based plastics can easily replace the carbon footprint for petroleum-based plastics. However, refineries are needed in order to biodegrade these plastics, which many countries don't have the funding for. Though we do have much more to discover about the development and future of bioplastics. Further research is essential in order to make these discoveries feasible and more accessible to countries in hopes of solving the growing issue of plastic pollution.
Great. So now you've learned a thing or two about bioplastics.
Thanks guys. I gotta get going. I have class. I'll catch y'all later. Bye.
All right, we'll see you later.
Bye.